Hi, I'm Sean Conant from Cal Poly Pomona. This video is about the RMAX project sponsored by Northrop Grumman. This project is a collaboration between Cal Poly Pomona and San Luis Obispo's engineering departments. The overall mission starts with San Luis Obispo flying their RMAX helicopter autonomously in a search pattern over a designated area. The RMAX uses an onboard camera and image processing to identify a known target. However, their RMAX was grounded, so they had to use a contingency plan. That included using an RC plane that was flown manually in the test area. Once over a target, their image processing software detects red and sends a packet of data of the GPS location to Cal Poly Pomona's UGV. Once our vehicle receives the data, we then verify on the ground station that it is the correct location of the target. Once verified, the vehicle navigates autonomously using waypoint navigation and obstacle avoidance to the target location. After reaching the target, the ground vehicle uses image recognition to verify that the target has been reached.
Hi, I'm Mike from Cal Poly Pomona. This is real footage from our demonstration. I'll be explaining what's happening.
And in case anybody's missed it, the target that we're looking for is the giant red ball off to the left side of the runway.
Right now, San Luis Obispo is flying their airplane manually across the airfield. Once the GPS and all the information starts getting sent to the ground station, then they'll have a go-ahead to start the mission. Once the mission is started and they start receiving packets, they will then wait for basically packets that say they have ran over something that's red and give back that target location. So we're just going to wait till they fly around and we'll start receiving some packets pretty soon.
The computer vision guys have implemented.
Target acquired.
As you can see, the red ball on the bottom of the screen, this is their target. Let me pull up a map. This is actually our ground station, so we can see in retrospect of where we are to the red ball and where the airplane is to the red ball. They continue to fly, making a few passes over the red ball. However, they were picking up a lot of false positives on the runway and off the runway. These are the coordinates that we received from San Luis Obispo. It's an air vehicle. We had to toss all these out and manually enter it into our vehicle, the waypoint coordinate, because none of them are close enough to the red ball. These are the waypoints we entered. The first being a safe location. We always enter our first waypoint somewhere safe to start the mission. So the UGV will go out to the first point. After that, the second point is usually our target location, which is the red ball. But we can have multiple waypoints, as many as we want, but for now we just need two. This is our UGV, unmanned ground vehicle, first going to our first waypoint. After it reaches that waypoint, it will then go to the target location, which is the red ball. We always have someone with a laptop making sure that it's following what it's supposed to be doing, its battery life and power, and just so we don't lose control of it. He can switch over to manual control anytime. He's just monitoring it. Our ground station actually can communicate to our ground vehicle up to 2 miles away, line of sight though. Without line of sight, it's probably around a football field. And the UGV has a battery life around 20 minutes, and its max speed is a little below jogging. Pretty cool. We reached the target successfully. We usually use image processing to verify that we reached the target, however that's offline. So we came up with another way of doing it, which is using LIDAR, and we can visualize this on the ground station. So this is obstacle avoidance during the demonstration. We started out by jumping in front of it a little too early, so it couldn't detect it in time. It still went around it, but as the video goes on, we will start out farther away and it will do just fine in avoiding people and obstacles. LIDAR is our main sensor. It's up front, but we also have sonar and front and back, but we're not using that right now. Thanks for watching the video about our demonstration. Now we're going to go into some detail about our design